When we're putting together Lewis structures, sometimes you might come across 2 different Lewis structures or 3 different Lewis structures for the same molecule. You might think of multiple arrangements for those electrons, and in this case, we can use formal charge to help determine what configuration is the correct one or the more correct structure as opposed to the other Lewis structures that were generated when multiple are possible. And to determine formal charge, it's simply done by subtracting the number of assigned electrons from the group number of the atom in question. And so if we take a look, hydrogen is group 1 on the periodic table. So hydrogen wants 1 electron assigned to it. And I know this is a little bit different than how we were counting electrons toward the octet, but I'll break down how we assign electrons and how we count those assigned electrons. Because remember, in this structure, in this covalent bond between carbon and hydrogen, we have 2 electrons represented here by that covalent bond. And for the 3 bonds between carbon and nitrogen, right, we're going to have 6 electrons represented there, and then the lone pair electrons are represented on nitrogen. And I'll do the same over here for the other Lewis structure for this compound. My 2 electrons there, my 6 electrons here for that triple bond, and then the 2 electrons assigned to carbon. So to determine the number of assigned electrons, we count 1 electron in each covalent bond. So in this covalent bond between carbon and hydrogen, right, I'm going to count 1 of those electrons as belonging to hydrogen. So hydrogen has 1 electron assigned to it. For carbon, okay, I'm going to count this 1 electron from the carbon-hydrogen bond, and I'm going to count 3 electrons from nitrogen for a total of 4 electrons assigned to that carbon. And then for nitrogen, we're going to count the 3 electrons from the carbon-nitrogen triple bond, and the last component of calculating the number of assigned electrons, you count 1 electron in each covalent bond, you count all the electrons as lone pairs. So we're going to assign 5 electrons to nitrogen, 3 from the carbon-nitrogen triple bond, and 2 as lone pair electrons for a total of 5 electrons. For the group number, hydrogen is group 1. We go over here, carbon is group 4, nitrogen is group 5. Subtract those. Okay, I should have a 0 charge there, a 0 charge here, and a 0 charge there. Now for the next Lewis structure, we'll do the same thing to determine the formal charge. Right, 1 electron for each covalent bond. So I go to hydrogen, and I still only have 1 electron assigned. Now I go to nitrogen, and I have 4 electrons assigned to nitrogen. 1 from the covalent bond to hydrogen, and 3 from the carbon-nitrogen triple bond for 4 total electrons assigned. I look at the carbon, and I have 5 electrons assigned. 3 from the carbon-nitrogen triple bond, and then 2 lone pair electron for a total of 5 electrons assigned to that carbon. So carbon is group 4, it wants 4 electrons assigned, it has 5 electrons. Now we go and subtract those. Okay, my charge on hydrogen is still 0. My charge on nitrogen now is +1, and my charge on carbon is -1. So now, yes, this is a Lewis structure. Yes, I've assigned all the electrons I have to assign. That being said, it is not the best Lewis structure because I am putting a charge, a formal charge, on nitrogen and on carbon. So the best structure, the most likely structure, is the structure that carries the lowest amount of formal charge. We want the fewest number of atoms carrying charge for the least overall charge on the molecule. There will be instances when you come up with a Lewis structure and you have to assign charge, right? We know polyatomic anions and cations that carry a formal charge. So there are Lewis structures where charge is required. That being said, we want to have the lowest charge possible, and if we have to assign charge, we always want to make sure that a negative charge is assigned to the most electronegative element, and a positive charge is assigned to the least electronegative element in that Lewis structure. So if we go back to the Lewis structure we came up with, we have a positive assigned to nitrogen, a negative assigned to carbon. Nitrogen is more electronegative than carbon. So if possible, nitrogen should be carrying a negative charge, and carbon should be carrying the positive charge. We've assigned it the opposite way given the electron configuration that we have. So the next slide, we're going to work through one more example of formal charges and Lewis structures and helping determine the best Lewis structure. So here's a question for you. What is the best Lewis structure for this nitrate anion? And I'm going to ask you to assign charges where appropriate. That's going to help us determine what is the best Lewis structure for this nitrate anion. So the first step, we want to determine how many valence electrons we have to assign. So I've got nitrogen and I have 3 oxygen. So the electron configuration of nitrogen, right, would be helium, 2s2, 2p3. There are 5 valence electrons in nitrogen. For oxygen, I have 6 valence electrons. It's helium, 2s2, 2p4. So I've got 5 valence electrons here. I have 3 oxygens at 6 valence electrons each for a total of 18 valence electrons. And on the nitrate, I also have a negative charge for 1 extra electron. So I've got a total of 24 electrons to assign in this nitrate anion. So I'm going to place nitrogen in the center, and I'm going to surround it with my 3 oxygens. So 1, 2, and 3. I have 24 electrons to assign. I just assigned 6 of those electrons. So I've got 18 electrons left. Let's take a look. Let's fill the octet for the outer oxygens. So 1, 2, 3, 4, 5, and 6. That makes 8 for that oxygen. 1, 2, 3, 4, 5, and 6 makes 8 there. And 1, 2, 3, 4, 5, and 6 makes 8 there. So now if we take a look, 6 and 12 and 18, I've assigned all 18 electrons, valence electrons that I had to assign. I've filled the octet for oxygen, but we should stop and say, wait a minute. If I look at nitrogen, nitrogen only has 6 electrons assigned to it. So number 1, nitrogen is breaking the octet rule. So if we didn't catch that mistake, the other thing we could do is determine formal charge. So let's look at the formal charges. To determine formal charge, right, we need to look at the group number. So oxygen is group 6. Nitrogen is group 5. So nitrogen is group 5, and of this nitrogen, right, how many electrons do I have assigned to it? I have 1 electron from this bond, 2 electrons, and 3 electrons assigned to it. So my group number is 5, and I have 3 electrons assigned. That's going to give me a total charge of +2. For the oxygens, oxygens are group 6, and I have, for each of the oxygens, I have 6 electrons assigned as lone pair electrons, and then 1 electron assigned in this covalent bond. So I've got 7 electrons assigned to each of those oxygens for a charge of -1. So I've got a minus, and a minus charge, right? Those electrons, that total 7 came from 6 lone pair electrons, 6 electrons there, and then 1 electron from this covalent bond for a total of 7 electrons assigned. 6 minus 7 minus 1. So if we look, I have +2 on the nitrogen, and I have a -1 on all the oxygens. Overall, my total charge is still -1 because That +2 is canceled out by 2 of the -1s from oxygen. Overall, the charge is -1. But maybe I can come up with a better Lewis structure for nitrate anion. So back to the drawing board. Nitrogen goes in the center, and I will surround it by my oxygens. So 24 electrons, I just assigned 6 electrons, 18 left to assign. Okay, I'm going to fill the octet for oxygen. There's 6, and there's 12. Now, remember before, I did not fill the octet for nitrogen. So let's give 2 more electrons to nitrogen in the way of forming a nitrogen-oxygen double bond. So now, this oxygen has 4 electrons assigned to it through bonding, through the nitrogen-oxygen double bond. That means I need to assign 4 more electrons. So 1, 2, 3, and 4. So now let's take a look. I've assigned 12, 13, 14, 15, 16 lone pair, and then 2 more electrons, right, in this nitrogen-oxygen extra bond that I added. I've still assigned 18 electrons. So let's figure out which is the better Lewis structure. Taking a look at my formal charges, if I look at nitrogen, well, nitrogen is still group 5. That didn't change, but the number of electrons assigned to nitrogen did change, right? I've got 1 electron in each of these covalent bonds. And so I'll just draw out, right? We'll think of that as 2 electrons there, 2 electrons there, and then 2 electrons here, and then 2 electrons here. So for that nitrogen, right, I have those 4 electrons assigned to it. So group 5 minus 4, I should have a charge of +1 on that central nitrogen. For the oxygens, oxygen is still group 6, so that didn't change, but the number of assigned electrons did. If I look at this top oxygen here, I see that in this top oxygen, I have 1, 2, 3, 4, 6 electrons assigned. 4 in the lone pairs, and then 2 that are shared with nitrogen. So the charge here is 0. That oxygen is neutral. So in general, if oxygen is in a double bond, it will have a charge of 0. I look at the 2 remaining oxygens, which are still group 6, and take a look at the total electrons assigned. I have 6 lone pair electrons, and I have 1 in a bond with nitrogen. So I still have 7 electrons assigned here for a charge of -1, and I'd have the same over here with a charge of -1. So in general, when oxygen is in a double bond, it's neutral. When oxygen is in a single bond and it has 3 lone pairs of electrons on it, it will have a charge of -1. So now comparing these 2 Lewis structures, right, the Lewis structure on the right is the better Lewis structure. I've assigned less charge, and I have fewer atoms carrying charge in this structure. The overall charge is still -1. It still is nitrate, but this would be the best Lewis structure. The better Lewis structure. Right, I have fewer atoms with charge. So hopefully that helps figure out formal charge.